Okay, this is a continuation of stochastic process problems, and I'm going to explain very important problem. So I already told you in the class itself, this is very important problem. A known initially contains five black balls and five white balls. The following experiment is repeated indefinitely, and a ball is drawn. What is the experiment? A ball is drawn from the urn. If the ball is white, it is put back into the urn, otherwise, it is left out. Let xn be the number of black balls remaining in the urn after n draws. If is xn is a Markov process, find TPM, find the transition probabilities, find the two-step Markov chain, and what happens to xn. So like this. So first of all, I'll explain the process. Okay, here I'll explain. No, it is given that. Okay, 1 second. Okay, so what is the question? An urn, maybe a bowl. Some bowl is there. In that bowl, by five black balls, five white balls. Okay, from the urn, suppose if I take a white ball, I'll put back into the urn again. Okay, suppose I'm taking. Suppose if I get black ball, I left out. Okay, then black balls will be four only. Black ball will be reducing. Okay, after reaching zero, and next time if I get white ball, I'll put back. Next time if I get again, if I get white ball, I'll put back. If I get black ball, I'll left out. Okay, and like this, black balls will be reducing. Once it reaches zero, we get only five white balls. So this is the process. This happened indefinitely. Okay, so how many black balls? Xn, let xn be the number of black balls exists in after n throws. How many black balls will be left? We get five, four, first five, four, three, two, one. If I get black ball, I'll throw it outside of the bowl. If I get white ball, I'll put back into the urn again. So these are the states. So we can write in ascending or descending order. I'll write in the zero also. You may get zero black balls also. Zero, one, two, three, four, five. How many states? Six states. P is equals to 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Like this, you write it. Okay. And so we write like this. Once if we reach zero black balls, next time we cannot be increased. We may not get 1 to 5. Definitely we get only zero black balls. Left side is the present black balls number. This is next black ball numbers. Black balls won't be increased. It will be decreased. Maybe same value. Suppose there are five black balls. Then next time, if I get white ball, we only five black balls will be left. If I get black ball will be reduced and we get four. Suppose there are four black balls. If I get white ball, only four black will be there. If I get black ball, I'll left out. So we get three black balls. Suppose there are three black balls. If I get white ball, three black balls will be left as it is. And if I get black ball, sorry, first if I get a white ball, I'll get exactly three black balls. And if I get black ball will be reduced. Like this, we get it. Okay. And next, suppose once if we reach to zero black balls, it won't be increased. So sure case, next time definitely zero black balls. Black balls cannot be increased. These are all impossible cases. 1 to 5 impossible cases. So zeros, this is sure case. So we get like this. Okay. And next, 1. Here in this case, what is 1? One black ball and 5. Always there will be 5 white balls. Okay. One black ball and 5 white balls. The present we have only one black ball. So if I get one black ball, next time it can be 1 or 0 only. 1 or 0. The remaining all are impossible cases. So put zeros there. 0, 0, 0, 0. So 1. Okay. So 1 to 0. So present one black ball, next zero black balls. Zero black ball. That means we got a black ball. That's why it is reducing. What's the probability of getting black ball? Favorable number of cases, only one. And favorable number of cases, one. And total number of cases, 1 plus 5, 6. Like this. Okay. And next, present one black ball, next also one black ball. That means we got a white ball. What's the probability of drawing white ball? Favorable number of cases, 5. Total number of cases, 1 plus 5, 6. Like this. And left side, we got 2. What is it meaning of 2? Here in this case, 2 black balls. Present 2 black balls and always there will be 5 white balls. Present is 2 black balls. Next can be, if I get black ball, we get 1. If I get white ball, I get 2. Black ball will be left as it is. It cannot be reduced to directly 0 or directly 3. It cannot be increased. So impossible cases. What are the impossible cases? 0, 3, 4, 5 are impossible cases. Okay. Okay. And so 0, 3, 4, 5 impossible cases. We get only 1 or 2. Suppose present is 2 black balls next to 1 black ball. That means black balls are reducing. Reduce means we got black ball. What's the probability of drawing black ball? Favorable number of cases, 2. Total number of cases, 2 plus 5, 7. Next, present is 2 black balls. What is the probability of next also 2 black balls? So black balls are not reducing. That is, we got white ball. That is favorable number of cases, 5. Total number of cases, 2 plus 5, 7. Like this. And next, 3 black balls. Present is 3 black balls. And definitely always there will be 5 white balls. Okay. And present is 3 black balls means next time if I get black ball, I'll get 2. White ball, I'll get 1. The possible values are only 1 and 2. Okay, sorry. 2 and 3, sorry. 2 and 3. If I get a white ball, the black balls will be same. 3 black balls only. Okay. So the possibilities are only 2 and 3. Remaining all are impossible. Impossible cases, put zeros. Okay, only 1 and 2, 2 and 3. We need to find the probability. And present is 3 black balls next to 2 black balls. That means black balls are reducing. Reducing means we got the black ball. What is the favorable number of cases is 3. Total number of cases 3 plus 5. 8. Okay. And next, present is 3 black balls. Next also 3 black balls. That means black balls are not reducing. That is, we got white ball. So that is favorable number of cases 5. Total number of cases 8. Like this, here also we get zeros, 4 black balls, and 5 white balls. That means 4 by 9, 5 by 9, 0. The same way, these are impossible cases, and 5 black balls and 5 white balls. 5 white balls, 5 to 4. That is favorable number of cases. 5 black balls, 5 by 10 and 5 by 10. Like this, we get. Okay. So this is the TPM. Just now written. This is a big TPM. Okay. And question. What is the first bit? Is Xn is a Markov process? Yes, definitely. So the Markov process means it depends only on the present value, but not on past values. So it's definitely number of black balls will be depend on the present values only. There are only 2 black balls. Next time will be 1 or 2. There is no need to check the previous values. So definitely it's a Markov process. It's a Markov process. The number of Xn of black balls independent of its past values. It depends only, xn plus 1 depends only on xn, but not on the past values. Just previous values enough. The remaining values we no need. That's why it is Markov process. Find TPM. So this is the TPM. Find transition probabilities. So transition probabilities is nothing but these are the values. 0, 1 by 6 is 5 by 6, 2 by 7, 5 by 7. These are all transition probabilities. What is 1? How can you say? Present is 0, next value is 0. So xn is 0, xn minus 1, previous value. Suppose 0 is the present value. Okay, xn is equal to 0, xn minus 1 is 0. Xn is equal to 0. Given that the previous one, xn minus 1 is 0, that is 1. And next, what is 1 by 6? Xn is equal to 0, given xn minus 1 is equals to 1. Xn is equal to 0, xn minus 1 is equals to 1. That is 1 by 6. What is 5 by 6? Xn is equal to 1, given xn minus 1. Previous one is 1. Xn is equals to 1, xn minus 1 is equal to 1. That is 5 by 6. Like this, you write all the values. I am explaining another example. What is this one? Next, what is the probability of 4? Xn is equal to 4, given xn minus 1 is equals to 5. That is 1 by 2, or 5 by 10, or 1 by 2. Okay. Xn is equal to 4, xn minus 1 is equal to 5. That is 1 by 2. Okay. And what is this value? Xn is equals to 5, given xn minus 1 is equal to 5. Xn is equal to 5, xn minus 1 is equal to 5. That is 1 by 2. Remaining all zeros. Actually, we have to write all 6 by 6, 36 values, 36 probabilities we have to write. But I'm writing only non-zero values. I'm writing only non-zero values, remaining all zeros. We can simply say that remaining all are zeros. Okay. And this is very, very, very important problem. Okay. What happens to xn? So find two-step Markov TPM. That is for fourth step, two-step TPM. Okay. Two-step TPM means we need to find p square. How do you find a p square? This is a very big, big problem. Here in this case, we have to multiply, nothing to do. 1 into 1 plus 0 into 0, 0, 0, 0 into all these things is 0. So we get 1. So just practice how to multiply. So this one into this one, you multiply and get this value. One thing I'll tell you, they give you exactly 5 black balls, 5 white balls in exam. They won't change the number. They may not ask like this, 6 black balls, 6 white balls, or 4 black balls, 4 white balls. In exam, if they ask you, they ask only these values. They won't change the values. So just keep in mind, once if you multiply, if we practice now in exam, you can get these values very easily. Okay. Second time in exam, so you can do it very easily. So just practice right now. You just practice multiplication of these two. Okay. And last point. What's the last point? What happens to xn as n approaches to infinity? So what happens to xn as n approaches to? So xn value as n tends to infinity. That's the question. What happens to xn value as n tends? What is xn value? 0 to 5 only. Suppose whatever may be the present values, if I do it indefinitely many times, infinite times, xn, so eventually the all 5 black balls will be left out. If I do it so many number of times, 100 times, 1,000 times, if I n tends to infinity, 1,000, 1 lakh, it can be 1 crore, infinite times. If I do it infinite times continuously, definitely 5 times we get black balls. So xn value will be what? 0. Definitely 0 black balls if I do it continuously. Okay. So like this. What happens to xn means the value of xn is equal to 0. Xn is equal to 0 as n tends to infinity. Find p power n. That's also in the bit, included in the bit. Okay. And okay. So use your answer to guess the limit of p power n as n tends to infinity. As n tends to infinity, we need to find p power n. P square, like we have found p square, p cube, p power 4, and so on up to p power n as n tends to infinity. That means whatever may be the values. Suppose there are zero black balls, after infinity times, there will be only zero black balls. Suppose there are one black ball, after infinity times, there will be only zero black balls. If there are only two black balls, after infinite times, you get zero black balls. So zero is the sure case, whatever may be left in present. So 0 is the sure case. So the first column will be ones. Remaining all are impossible cases. You may not get black balls after infinite times. You won't get these values. You won't get black balls. Black balls will not be left. That's the question. Okay. And one second. Gambler ring problem I have explained in this classification of states classification of states video. You check it at the end of classification of states. That's very, very important problem. That is what you get uh, gambler ring problem. I have given some formula also. That's also very, very, very important. Okay. So all the best.